Hello to everyone. Here we are again for the new video of our chemistry subject. As we know that we were in the last lecture at the topic of haloalkane and the haloarene, where we taught about the preparation of chloroform and iodoform. So now we have another topic related with this chapter, which is also an important topic, and it is chemical properties of haloarenes. What is? It is chemical properties of haloarene. Now, as we know that the haloarenes gives us Se2 reaction, that means substitution electrophilic 2 reaction. That's why it can easily react with the different compounds which can provide it electrophile. So we will start from our first reaction, which is known as halogenation. What? Halogenation of haloarenes. Here, haloarene will react with a compound which can provide it a halogen, and after that will form a compound together. That's why it is known as halogenation of haloarene. So this is what? This is chlorobenzene. Now when chlorobenzene is treated with chlorine in the presence of FeCl3 in the dark. Remember, this reaction should not be occurred in the presence of light. It should be occurred in the presence of dark. That is, in the absence of light. If the light will be present, then another compound will be formed. What is it? We will study in this lecture, but after some time. So, as we know that haloarenes are ortho-para-directed. Ortho-para-directed means it increase the electron density on the ortho position and the para position. That's why two different compounds will be formed. First is ortho chlorobenzene, and the second is para chlorobenzene. As in the ortho position, the both groups are comparatively closer with respect to the para position. Because here the groups are closer together, then they have steric hindrance for each other. And that's why they will form less amount of the product, and therefore this is a minor product. And what is it? It is a major product. Approximately 21% minor product is formed, and approximately 79% of major products is formed. So this is halogenation of haloarene. Now we are moving towards our next reaction. Okay, and that is nitration of haloarene. In the nitration reaction, we react the haloarene with nitric acid. It may be dilute and it may be concentrated. Both are correct. And whenever you have need to do nitration, the nitric acid should be taken along with sulfuric acid. The concentrated nitric acid and the concentrated sulfuric acid together known as nitric mixture, which are responsible for doing the nitration of our different organic compounds, as in this case. So here we are taking concentrated nitric acid and the concentrated sulfuric acid. Both together are known as nitric mixture. What does it know? It is known as nitric mixture. Then HNO3 is dissociated into the two different parts. First is NO2 positive and second is OH negative. Out of which NO2 positive is our electrophile, which is our attacking species. Attacking species. Now it will attack on the pi bond of the chlorobenzene because pi bond contains electron and it has positive charge, so the positive negative attract each other. Now here when it will come closer to this H, it will replace the H, it will substitute the H in the form of the proton. As it does not contain electron, therefore the removal of the hydrogen will be occurred in the form of proton. That's why it is known as substitution. And the second thing, if you will observe at the transition state, you will see that the NO2 positive and the H positive, both ions are connected with the central carbon atom. That's why it is known as sp2 reactions. So these all belongs to the sp2 mechanism. Now it may form orthochloronitrobenzene and para-chloronitrobenzene. Both are correct. So we are taking here its another thing. We are giving first to the chlorine because in the alphabetical order the chlorine comes first, and in the second nitro, the nitro and come after that. So we may take the 1 and 4. So what will be it? It will be 1 chloro, 2 nitro, benzene. Yes, we can also write down the name of this compound in this manner. What? 1 chloro. Why? Because the chlorine C alphabet comes first with respect to the nitro N. Then 2 nitro and in the last benzene. I am writing down the benzene here as I have not discussed enough to there, but you should write down the whole IUPAC in a single row. So here it now will be 1 chloro, 4 nitro, and in the last the root chain is benzene. Again it will be minor product and it will be merged. I am not mentioning here because you understand this thing already. Okay, so take a flash view on this reaction because I am going to rub this board again to do our next reaction, which is sulfonation. So now we will do sulfonation. What? Sulfonation. In the sulfonation, we react haloarene with the sulfuric acid. Again, the sulfuric acid will be dissociated into the two different parts. One is the OH negative ion and the second is the SO3H positive ion. So, what are the different ions? First is the SO3 positive ion, SO3H positive ion, and the second is OH negative ion. the SO3H will come here, and in the second step, the SO3H will come here at the para position. Again, it will be minor product, it will be major product, and what we have obtained? We have obtained water as a byproduct. To write down the byproduct, it is not mentioned in my previous section, the byproducts. So why? Because to mention the byproduct, to write down the byproduct, it is not compulsory, it is not necessary, it is totally depend upon you. If you want to write down the complete whole balanced reaction, you should write down the byproduct also. Okay? Okay. So what is the name of this compound? It is orthochloro, because they are at the nearby with each other. That's why orthochloro sulfonic acid. So what will be the name of this compound? The name of this compound will be para-chlorosulfonic acid. That's it. Okay? It is again quite easy. You may have that of few questions again from here. And if you have, then you should ask. Okay. So we are moving towards our next. What was that? That was the sulfonation. I just forget to mention the name of this reaction, but it is just only the sulfonation of haloarene. Okay? Okay. So the next is alkylation of haloarene. What is alkylation of haloarene? It is also known as Friedel-Crafts alkylation, as the Friedel-Crafts has two different types. First is the alkylation, we are doing this, and the second is acetylation or the acylation. There is a difference between the acylation and the acetylation. Acylation means that whatever the R group you want, you can take, but in the acetylation you will have to take CH3CO positive, only CH3CO positive. Okay? Okay. So in the alkylation, of the haloarene, you react it with RX in the presence of anhydrous AlCl3. So on heating, obviously it will give us two different products. One will be minor, second will be major. Okay. So the H will be moved out with the Cl to form the HCl, which is our byproduct, and that position can be completed by this CH3 like this. Here I just write down the major product firstly and the second minor product, that doesn't matter. We can easily interchange it. So this is what, whenever the CH3 is attached with the benzene, it is known as toluene, as the toluene is industrial name. So these all are para-chlorotoluene and the orthochlorotoluene. So this is para-chlorotoluene and this is orthochlorotoluene. Okay? Okay. So here what I did, I just substituted the H plus ion with the one carbocation belongs to the alkyl group, alkyl carbocation, CH3 positive. So that's why it is known as alkylation. Now we are moving towards the acetylation. So for the acetylation, what was that? That was chloromethane. It is chloromethane. So here I am taking again my chloroengine. It will use as a substitution reaction on the position of alkane para Simple. Now I am taking CH3COCl. That means ethanol chloride or the acetyl chloride, which when heated in the presence of anhydrous LCl3 gives us HCl as a byproduct, like in this alkylation, and the substitution will be occurred at the place of alkyl pair. So here the positive charge will come on the carbon, as whenever the bond will be dissociated, it will be hydrolytic. The chlorine will withdraw the electron of the carbon towards itself by the help of the LCl3, and that's why the carbon will form the carbon-cation positive charge, which is electrophile obviously. That electrophile will attack on the ortho or the para position. So what we get? We get COCH3 or the again COCH3 at the para position. COCH3 at the ortho position, COCH3 at the para position. They are known as orthochloroacetophenol, para-chloroacetophenol. Why acetophenol? It's quite easy. It is ketone, RCOR, which has the suffix on. This is acid group, ACET, not acid, it's aceter, ACET. Okay? Whenever the benzene has one remaining valency, it is known as phenyl. So that's why they are present at the ortho position with respect to each other. That's why ortho. It is chlorine, that's why chloro. Now the acid word comes from them. CH3CO, what is it? It is acid. So ortho, chloro, then aceter. Now, whenever the benzene has remaining valency, it is known as phenyl. So we have taken the word PHEN from that. So it is, I am mentioning the remaining name here. You should mention the name or write down the name in a single name. So PHEN, phen, while has been removed. And what is the suffix for the ketone? It is on, ONE. So what is this? This is the orthochloroacetophenol. Pronounce it one more time with a more fluency as fast as you can. You will have to stop at this position. Orthochloroacetophenol. That's why O is splashed, which gives us a comparatively more fluency to pronounce this word. Orthochloroacetophenol. It's quite comfortable to pronounce it like the orthochloroacetophenol. That's why it is known as orthochloroacetophenol. The remaining compound is the para. Okay? So this is known as Friedel-Crafts alkylation. What is the name of this reaction? Friedel-Crafts alkylation. And this is known as Friedel-Crafts acylation or the acetylation. Friedel-Crafts acetylation. It is better for us to understand the reaction with the mechanism. So that mechanism is also teaching in your school, and if you want you can come to school. It will be more beneficial for your study, and if you cannot, then you should learn from these online videos. Okay, so for this video, for this lecture, our topic has been completed. You should just study it with the proper manner, revise it again and again. If you found any kind of difficulty, then you can come to school for your tuition. Okay, till then, stay on your home and keep healthy yourself. Keep clean your country also. Thank you.